Hello, hi everyone. This is Abitha. Welcome to ATR Speaks. Today we will discuss about basic Java interview questions and answers part 5. So let's get straight to the topic. First question is, what is encapsulation, and explain with examples. Answer is, encapsulation refers to keeping all the related members, that means variables and methods, together in an object. We can create a fully encapsulated class in Java by making all the data members of class private. Now we can use setter and getter methods to set and get the data in it. Here, objects should hide their inner workings from the outside view. We just go through the example. In this example, we have a class named myMarks and there are two private variables, name and marks. Here, the getter and setter methods provide read-only and write-only access to our class fields. Next is advantage of encapsulation in Java. First point is, by providing only a setter or getter method, you can make the class read-only or write-only. In other words, you can skip the getter or setter methods. Next point is, it provides you the control over the data. Suppose you want to set the values of id which should be greater than 100 only. You can write the logic inside the setter method. Next point is, it is a way to achieve data hiding in Java because other class will not be able to access the data through the private data members. Here, the encapsulate class is easy to test, so it is better for unit testing. The standard IDs like Eclipse are providing the facility to generate the setter and getter methods. So it is easy and fast to create an encapsulated class in Java. Next question is, what is abstraction? Abstraction is a process of hiding the implementation details and showing only functionality to the user. Another way, it shows only essential things to the user and hide the internal details. For example, sending SMS where you type the text and send the message. You don't know the internal processing about the message delivery. So, abstraction lets you focus on what the object does instead of how it does it. There are two ways to achieve abstraction in Java: by using abstract class and interface. In this example, you don't know the internal working of car, only showing functionality to the user. Next question is, what is the difference between an abstract class and an interface, and when should you use them? First point is, abstract class have executable methods and abstract methods, but an interface can have only abstract methods. From Java 8, it can have default and static methods also. From Java 9, it can have private concrete methods and as well. Say that concept of default method is introduced in Java 8 to add the new methods in the existing interfaces in such way so that they are backward compatible. Backward compatibility is adding new features without breaking the old code. This point is, abstract class may contain non-final variables, but variables declared in Java interface are by default final. Point is, abstract class can have final, non-final, static and non-static variables. The interface has only static and final variables. Abstract class can provide the implementation of the interface. Interface can provide the implementation of an abstract class. Abstract class can be extended using the keyword extends. Java interface can be implemented using the keyword implements. Abstract class can extend another Java class and implement multiple Java interfaces. An interface can extend one or more Java interfaces. Abstract class does not support multiple inheritance. Interface supports multiple inheritance. The final point is a Java abstract class can have class members like private, protected, etc. But members of a Java interface are public by default. In this example, there is a class car with two normal methods run and brakes and one abstract method change gears. Here, change gears is implemented in the extended class Alto. In this example, there are two interfaces producer and consumer with perform and consume function respectively. Here, another interface producer consumer extends producer and consumer interface. Next is when to use an abstract class. First point is an abstract class is a good choice if we are using the inheritance concept since it provides a common base class implementation to derived classes. Next point is an abstract class is also good if we want to declare non-public members. In an interface, all methods must be public. Point is if we want to add new methods in the future, then an abstract class is a better choice. Because if we add new methods to an interface, then all of the classes that already implemented that interface will have to be changed to implement the new methods. Next point is if we want to create multiple versions of our component, create an abstract class. By updating the base class, all inheriting classes are automatically updated with the change. Next point is abstract classes have the advantage of allowing better forward compatibility. Once clients use an interface, we cannot change it. If they use an abstract class, we can still add behavior without breaking the existing code. Final point is if we want to provide common implemented functionality among all implementations of our component, use an abstract class. Abstract classes allows us to partially implement our class, whereas interfaces contain no implementation for any members. Next is when to use an interface. First point is interfaces are best suited for providing a common functionality to unrelated classes. Point is interfaces are a good choice when we think that the API will not change for a while. Next point is interfaces are also good when we want to have something similar to multiple inheritance since we can implement multiple interfaces. And the final point is if we are designing small, concise bits of functionality, use interfaces. If we are designing large functional units, use an abstract class. Next question is how do you express an is-a relationship and a has-a relationship? A relationship in Java means different relations between two or more classes. For example, if a class car inherits another class vehicle, then we can say that car is having is-a relationship with vehicle, which implies car is a vehicle. In Java, we have two types of relationship, is-a relationship and has-a relationship. In is-a relationship, whenever one class inherits another class, it is called an is-a relationship. The is-a relationship is expressed with inheritance. Whenever an instance of one class is used in another class, it is called has-a relationship. Has-a relationship is expressed with composition. So, two of the main techniques for code reuse are class inheritance and object composition. For example, house is a building, but building is not a house. So, inheritance is unidirectional. Here, inheritance use extends keyword. Composition is used when house has a bedroom. It is incorrect to say house is a bedroom. Composition simply means using instance variables that refers to other objects. The class house will have an instance variable which refers to a bedroom object. Example, class house extends building. So, here use extends keyword for representing is a relationship. In has a relationship, class house has a bedroom object. And the last question is, what is the difference between composition and aggregation? Aggregation is a part of a whole relationship where a part can exist without a whole. For example, a line item is a whole and product is a part. If a line item is deleted, then corresponding product need not be deleted. So, aggregation has a weaker relationship. Composition is a part of a whole relationship where a part cannot exist without a whole. If a whole is deleted, then all parts are deleted. For example, an order is a whole and line item are parts. If an order is deleted, then all corresponding line items for that order should be deleted. So, composition has a stronger relationship. So, today's part is over. I hope you like my video. Please share and subscribe. See you next time. Bye bye.